Listen, I just want to take a moment and ask you to subscribe if you haven't done that already, and share the video and give me a thumbs up. Those three things go a long way in supporting this channel, and I really appreciate it. Thank you.
So what we're doing here is haven't done much with this transformer. Actually, I haven't done anything with it yet. Just check and see how easy it is to make it resonate. This one's grid input coming in 60 hertz, 120 volts. And, over here is output current, input, output. Ultimately, we'll go into this heat sink heating element. Nice resistive load, maybe a little on the inductive side. Uh, 10 amps on this side. And barely anything registering on the input. 132 volts output. Alright, so I'm going to use these yellow leads for resistive load. Yeah, right here. So let's 10 amps. 9.8, almost 10 amps. Going into the load. Still really anything registering on the amp. It's probably about 200 or 300 milliamps. I'll have to get a digital gauge. Where is it? Temperature isn't rising at all. We're still 93 degrees. Oh. Yeah, 92, 93. So we're driving this coil. We have a capacitor across the coil on this one, which I'm going to lift off. And our output decreases big time. So this is AC cap is 60, 32 UF. I think this, and this is 60 UF. Yeah, so these two capacitors are on the 100 volt tap. Other than that, the 100 volt tap is just going to these two capacitors, which we added up to what, 92, I believe. And that's it. We're not taking any power from there. And this one over here is pretty much running without any capacitors on it at this point, but we're going to be changing that in a second. So we've got still almost 10 amps. We're going to take the 7.5 UF and this green one, which is the other side. So what I've got on this is a 110 volt, 100 volt winding, and a 120 volt winding in series to equal 220 volts. So we're putting 120 in. I don't even, it's crazy with this transformer, because let's see what happens when I change the resonance on the middle core. Hey, we got 2 people watching. Yay. Thanks for stopping by. Doing some quick testing on this particular transformer. It's a 3-phase transformer. And the part number is actually manufactured from Schindler Elevator Group Corporation. The part number is 222981. 50-60 hertz. Capable of probably like 12 or 1400 watts. Getting almost 10 amps at 108 volts under load. I'll have to measure the impedance of this, but what this is a I believe it's a 5,000 or 6,000 watt heater coil that potentially has either 220 volt taps or series it up for 240 volts. It's getting a little long. Still no change in temperature, 92 degrees. It's the same as air temperature right now. It's hot as fuck in Texas. Excuse my French. Yeah. No heat being generated on either side. If you watch on your mobile phone, you can probably pinch the screen off and should be able to see these. Yeah, don't bother. I just tried it on my phone because I'm monitoring on my phone. I can't see these, so. Using the web camera up there where you're looking down from. I really don't want to pull it down. So you're going to have to take my word for it. So we've got roughly a little over, it's just, I mean, this is just barely. Take that It's about 100 milliamps, maybe a little over 100 mils and 120 volts. Actually, accurate voltage from coming from the grid here is, I think it's 127. So you guys are going to do the math. And coming out was still 9.5 amps, almost 10. So it's like barely touching the 10 amp bar on the scale. So it's very strong 9 amps coming out. Right now we're 153. And if one of these caps are getting along, something's changed just a little. We were 160. Now the caps aren't more.
Listen, I just want to take a moment and ask you to subscribe if you haven't done that already, and share the video and give me a thumbs up. Those three things go a long way in supporting this channel, and I really appreciate it. Thank you.
That's serious over unity right there, guys. You gotta find a scrapyard around you. There are some kind of electrical supply, or maybe you go on eBay, or I've bought some nice transformers off of eBay. They're fairly cheap money, reasonable money, a couple $100. I mean, you can use something like this. You get a solar panel with a grid tie inverter, power this from the solar panel. A lot of the new solar panels now, they have all independent inverters, and they all combine together. The whole array will. But you can take the output and drive one of these setups, and then your output's a lot multiplied. So for one panel, you're probably going to end up with maybe 3 in output over here on this side. And it's a nice multiplier. Not violating any rules. I know this is that's nothing. No heat. Nothing being generated. Yeah, so I don't know if the winding ratio compared to the core size, I'm going to have to investigate why this is a little unique. And really, I think I'll have to try the other ones. So I think I can I can't do a snapshot, but Schindler Elevator Corporation. And the part number is 222981. Rated for 165 VA. So ultimately what this is a step down, either 208 or 480 on the primary side. And the secondary side is 100 volts. So that's just in a few minutes, just messing around with a few caps, not even bringing this cap substitute box out. And trying to resonate it. It looks like it's resonated pretty good. So this is 1.5 UF. I just want to see what this does for me. It's actually a high voltage microwave oven capacitor. So I'm sure there's a bleed resistor in there. I just want to add a little more capacitance to a little more. It's like 6 volts. So 1.05. 0.75. Let's see what this does. If the peak goes up, let's see which side the peak we're at. Oh yeah, okay. So that's even a bigger increase than this. So we're probably pretty close to the top. These wires are getting warm as hell. Yeah, 140 degrees on the wire. It's actually starting to wrinkle up a little. So that's just the current we're drawing through the load over here. Still the same temperature, 93 degrees. 93 all the way around. The core is. The capacitors are getting warm and all. And the load bank is, oh, it's hot. Almost 400, 380. 380. Yeah, 380 degrees. So, it feels like it. So 120 volts in. And I'm just going to call it 200 milliamps, but I think it's a little less than that. Coming in, which I'm going to have to set up the other scope probe in and use a 1 ohm resistor. And curious to see what my phase shift is on this. It's got to be pretty close to 90. Or maybe a little lower, who knows. Yeah, I've never seen a 3-phase transformer where you add capacitance to the unused core in the middle and you're running it single-ended. I've never seen the capacitor add that much output. But I would imagine if I don't do anything with the middle, which I'll probably do, is rearrange my windings and see if I can't get all that back. It might be just an impedance ratio between pole B and pole C, you know. So don't forget, there's a 3-phase transformer. So you got to think of your phases and degrees times 3. I don't know how long we've been on live, so it's probably a half hour maybe. Well, that's not bad if it doesn't change or it goes any higher than that. Hey, buddy. I'm sorry. I gotta pay better attention to the live chat. Over Unity Research Channel. How you doing, buddy?
Listen, I just want to take a moment and ask you to subscribe if you haven't done that already, and share the video and give me a thumbs up. Those three things go a long way in supporting this channel, and I really appreciate it. Thank you.
So these blue leads are going in this big rheostat. I am just going to go across the caps. Get this wide open. And the current there. Alright. That's shorted. We got a little peak. I wonder what the resistance is on that. $43. Yeah, $43. So that's interesting. LC circuit. Pretty much. To move this just a little. There's a lot of radiant heat right there. Alright, so we're still like under 200 milliamps at 127 volts coming in, coming out 159, 160 at almost 10 amps. What do you think? That's actually, this is acting way better than this one. I don't know if any of you guys remember this one that was in that couple of bit videos, and I had slimmed down, cut a lot off, and changed things, tuning and experimenting. But I mean, in essence, this was destroyed as a conventional transformer, three-phase transformer, but got things put pretty flat and made up that surface with some more silicon steel, so it still acts like it did before, but this, you don't see the main core on there or the shunt bars going from this end to that end on both sides. So $107. $107. So the three-phase transformer is warmed up to 107 degrees. Still hovering around 490 degrees on the resistive load. No heat increase on the capacitors. They're just the same as their temperature. What a beautiful sine wave coming out of that coil. Like this one here is, yes, it's not even moving. I mean, you can see the outline of it. Excuse me. For the input, and the output is even tougher to see. You can actually see the little white pinching in. I got my phone right here trying to do it, but it's at the 10 amp scale. You guys are gonna have to believe that. And I don't want to take that thing down. I got it all perfect. So I'm not going to post any bullshit, fake crap on here. It's not the way to go. Hey, Huey Yak. How you doing, buddy? I didn't even know you were here. I gotta pay more attention to the live chat. I'm not accustomed to having more than 2 or 3 people in here. Hey, we got 4 now. Hello. Oh. This thing's working pretty good. I don't know if you're still there, Flint. Oh, yeah, you are. Okay. Yeah, we got yeah, about just about 1,600. Yeah. And this is coming in. We're bringing the grid into here, and on the coil. The coil has got 92 UF total across 100 volt tap coil on the B, and C has got 20.75 UF to resonate at 1600 watts. So we're about 200 milliamps coming in at 127 volts. 3, 4, so let's call it 5 watts in. It seems kind of crazy, but I mean, there's nothing else going on. Here's the resistive load right here, which is hot as hell. That's attached to the final output, so we got a 100 volt winding in series with 220 volt winding, resonated with a little over 20 UF. And then the 92 UF is attached to the B coil, this is disconnected. I don't know if you can see the meters move, but comes alive. This thing literally comes alive. And this control current with the capacitors is it's nothing. It's just a tiny little spark. No, hardly any current there. It's just nothing. You can barely hear it. But that's enough to maybe what we're doing is the back EMF from C is getting trapped in here for a second, and somehow it's managing to push back at the right moment back to the source. On the input, we're through 100 and 220 and another 200. Excuse me, a 120 and another 120. So that's 340 volt input with being fed with 127 volts. So 120 volts per tap, and then so that's times 2, and then we've got one tap over here which has got 100 volts. So and all these windings are all isolated from each other, which is nice. So they're all seriesed up, so we're really reactive coming in. And we've been probably at this for about an hour now, and we're basically at 107 degrees. Just barely feel it warm. So the transformer's been running like this, drawing. Our load has been 10 amps, just a little under 10, with not much coming in. 200 mils at 127 volts, maybe 3.5 watts or something.
Listen, I just want to take a moment and ask you to subscribe if you haven't done that already, and share the video and give me a thumbs up. Those 3 things go a long way in supporting this channel, and I really appreciate it. Thank you.
It's crazy. Nothing else coming into here. That's just a scope that's on. I'm looking at the beautiful sine wave. This here is coming from the grid that goes underneath here. I'm actually going to pull this up so you can see that, and that's right here. So here's the white and the black. Black's going through the amp probe. I'm just putting it underneath this cord just a little to keep it from pulling down and pulling the alligator clips. So this is the grid coming in. That's the only thing coming in. Here's our load. $107 solid. It's not increasing, so I mean, I expected it to get warm. I really thought maybe it'd be like up in the high 118 or 20 or something like that, or maybe 130 degrees, but this is nothing. Fire would never need a fan on it. Man, I'd love to see how this acted in a freezer. We're gonna have to find me a little freezer. Put that in there. Run that at like 30 below, 25 degree, 30 degree below. You know, because at that, I wonder how, that'd be crazy if the output increased, but you know it's gonna. You know, I mean, heat kills. So, and it's squealing like a little piggy. Capacitors are at ambient temperature. Right in the 480 range for heat. I think this is amazing. Absolutely amazing. I didn't expect to see this much gain, but we got a very, very high cope here. And there's no shunt bias. Um, and I'm gonna try one, and already started the process of making them for the next size transformer, the bigger ones. I've got 2 extra cores that I cut the windings off and left the copper in the scrapyard, and they just brought the cores home because I plan on cutting them and using them for shunt bars, top and bottom. Yeah, it is amazing. How you doing, Doug? Glad you guys all made it in here. Um, it is. This is. I've never seen a bit perform like this. I mean, if I don't know if you guys can pinch the screen right now and zoom in, we're getting a little. You got a magnetic field coming off here. So with these Radio Shack, these are like brand new. I'll keep them in there. I protect them, and I still have the original boxes that these came in. I got 3 of them, but they're very accurate for AC. But I mean, they're also sensitive because I mean, I can just go near the core and sense any AC just showing up on the meter. So, but one clip being perfectly still, I mean, this is just like the needle is in between 0 and the little mark that's in between the next mark, which would be 5, and then the next mark, 500 mils, and then the next mark would be 1 amp. So we're under that, and we're right at that first little. It's like the red bar, the red needle is just on the very edge of 0. That's the only way to describe it. So that's our input, and if you pinch off the screen, this is the power feeding it, right? So I'm going to disconnect it. You can actually see just a tiny little swap. Now there's a big one because that was out of time. And that's, if your timing is wrong, then you can get a big peak on the meter. So back to 10 amps, back to 200 mils. Right around 200 mils, which is crazy. 92 UF across the 100-volt coil on coil B. So that's the only thing that we're doing there. We're not doing anything else. We're not doing anything with that power. And then 20.75 to resonate the full output using the 100-volt winding and another 120-volt winding for 240. 127 in, one's roughly right between 159 and 160 coming out at 10 amps. Just a teeny bit under 10 amps. This is nuts. Absolutely nuts. Never had a bit perform like this. And I've done one that was a little bigger than this, and I think I got, I was happy with a little over 4 times out. And that's a friend up north has got that up in Maine. He uses it for powering his LEDs because he has grow in shipping containers that are like literally underground. But he's all legal and everything. He just does that to get away from that's something you can manage, and he doesn't really cost him anything for heat being underground. Um, and it's a legal grow is what he's growing. But he grows. He added another shipping container, and he's growing vegetables as well. So like tomatoes, garden grown tomatoes underground. But he's been using a transformer like what we got going here. Um, and he's got solar. I think he's got probably a little over 10,000 watts in solar. Um, and I think when I was last up there, which was shit, a long time now, he had got these big batteries. They're lead acid, but they were huge. Yeah. And I thought they were glass, but they're actually clear plastic. But I think they weighed like 1,000 pounds a piece. 2-volt cell that was 4 feet tall and 2 feet wide. And big, lot of lead. I think it's I don't know if they're 4 or it might be 4. I think they're 4,000 amp hour cells, or maybe 5. I'm not sure. But he's got a 24-volt system that he runs with his inverter. So, um, but he's using to keep the power available for other things. So he's saving a lot running with and the LEDs agree with this setup. Yeah, still a lot of heat coming out. 490. All right, so now we're up to 110 degrees. Yeah, that's interesting. It's climbing a little. I wonder what the plateau will be. So 110 degrees. No heat on the caps. They're all 93, 92. Yeah. You know, it'd be nice if I wish YouTube would do it. Allow you to send a voice message on the live. How cool would that be? I mean, the chat's okay, but it'd really be nice to leave a voice message in the chat. Yeah. Last I checked. Yeah, there's no way of doing it. I don't see anything. Everybody should ask for that. Yes. Thank you. Thanks for doing that. Why couldn't I have put that in there? I'm an idiot. You know, I'm 3 beers deep into this project. Well, we're going to get another one. I haven't had beers in a while. And, yeah, it's been months since I even had a beer. So I've been enjoying a couple of them. Nice and cold. That's the best part. Oh. Yeah, that's still, what do we got here? It's come down a couple of degrees. It's now 91 degrees in Loras, Texas. And it's 6:30 at night. It'll be 80 degrees at nighttime, at midnight. It's never going to cool off ever again. Yeah. So I got to pick and choose my times out here unless I want to sweat. I got a fan blowing on me right now. Yeah, and I've got this stuff aside for a second. I got this guy here. This one, I can't wait to mess around with this one. I'll probably do this tomorrow, I hope. Yeah, 2650 VA, 208 to 480 Delta. You can actually star a Delta, wire a Delta. But that's the primary. And then the secondary is 190 volts at 8 amps and 95 at 95. Oh, at 8. So part number on this one is 222553. And it's Schindler Elevator Corporation is what it's labeled with. But I wonder who really made these for them. They resemble, I think it's Allied. Allied does this type of stuff. Yeah. Yeah, so it's going to be interesting to see. Would it be awesome to take this, to drive this one? That'd be crazy. Yeah. This one, drive this one. And then take this one and have that over here. Use this to drive that, That'd be really interesting if I can get it to 3 steps. I'm gonna have to try it. Let me get this on right. Yeah, them things aren't light. They weigh like 70, 80 pounds. Yeah. How I cut myself. Still drawing almost 10 amps. 111 degrees now. 111. Still 490 degrees in heat on that. I gotta push these power supplies back more because I want that to melt the face. The ambient temperature on the capacitors. Yeah, this is nuts. You know what I'm gonna do is I'm not gonna change any of this. I want to disconnect from the grid and get an inverter, a 12 volt pure sine wave inverter, and drive this. And see if I can't take a small portion of that 1600 watts and loop it back to charge itself. And maybe I'm going to try it directly off of these coils, but I may run another bit over here take the output of this resonated coil drive. Actually, I'm going to vector through a one-to-one transformer, a microwave transformer that you took two primaries and just put the thing back together, right? And put an AC bridge on the other side of that and take that and send that to the DC bank, the cat bank, to run the inverter. And then drive another three-phase transformer into A and do the same thing. Find out if that's needed on the B coil and resonate C again, and then take the output of that and use that to run my switching power supply. And take that switching power supply to charge the DC to the capacitor bank that's needed for keeping the inverter going that will be driving it, and see what's extra. I know last year I had my inverter system running with a bit. Just I didn't even spend much time resonating it. It was the way I left it the last time it was in the box. And I sent the output of the bit to a switching power supply to charge the 400 amp hours that they had, and I used it all week. We used it for a TV, we used it for fans. We were out of power for a while, and as long as there was at least 5 to 6 hours of inactivity or minimal usage, the thing would charge itself back up, and you could complete the cycle again for the next day and use the piss out of it. Yeah, it was 400 amp hours. Two groups of I don't know. They're about they're lithium ion, but they're about the size of a Group 27 battery. So a lot of storage. And the switching power supply is 50 amps, so it can charge itself back. I think I measured somewhere in the 40s at one moment. And I said, okay, well, let's see what happens. See if this is still going in the morning when I wake up. And it was. The fans were still going. Had two fans on there, so it was like probably, 30, 40 watts a piece for each fan because they weren't big. And the system was charging itself up. So, power nerds, yeah. We're all a bunch of power nerds. You don't have to have a little white tape in the middle of your glasses on your nose, you know. Yeah. They come in all forms. Yeah, this is amazing, guys. I mean, you write these part numbers down, and it's Schindler Elevator Corporation is the. I don't know who made them. They might have manufactured. They manufacture a lot of stuff, so I'm sure they're nicely built. What do we got for temp now? 104. Look, something's changed here. We were 110. Oh, I see what's going on here. The resonating caps come off. Ah. There we go. So there was a little less current, and yeah, that's like 3 amps. So this clip come off, which was going to this cap that was resonating over here. So there's a little decrease, and with the decrease, the heat drops. I mean, so that means the heat verifying. We got going on. We got a load over here generating a lot of heat. Probably cook a hamburger on that sucker. Still not much coming in over here. Barely moving the needle. We're still drawing 10 here. Almost 10. And that's it. I mean, the only other wire coming into the picture is here, coming from the scope, Antec, and that's it. Grid's coming in over here, connects to these two wires, the white and the black, neutral and the hot. Hot's going through the amp probe. 100-volt tap on this side, 120-volt tap there, and another 120-volt tap there. So we've got 3 independently isolated coils on one pole, seriesed up in phase. A lot of reactivity, a lot of reactance going on. Really reactive. And we're getting the real power out over here. It's crazy. Yep. Scope probe come off. There we go. Beautiful sine wave. Yeah, we're coming back up to 110 again. So 110 degrees on the transformer. A little right around 480 degrees of heat. (92 UF on pole B). Significant difference in output. No effect on the input. That's oh shit, it's hot. Yeah. You can see this needle here. Watch this needle move all the way to 10 amps. This one, it's not moving. Just a teeny little bit. About the width of the needle is all that moves. This is going through the black, coming on from the grid, right? This is real, guys. This is not bullshit. Real load. We have some wastes, but we have a huge advantage with the back EMF. We're dissolving it. Yeah, 111 now. 111 degrees. Still almost 10 amps. 200 mil input at 127 volts. This is nuts. Sorry, Doug, I didn't catch you. Let's see, what is the load? The heater? Yeah, there. It's actually a. The load is a heater core from an AC unit. So, electric heating core, and it's capable of handling 220. I'm only using 1/2 of the coil. This row, this one is not being used, but this one is being used. So that's attached to this, which I think looks like, I don't know how many ohms that was. I measured it. So yeah, so 20 UF, 20.75 UF to resonate. a 100-volt winding in series with a 120-volt winding. So it's about 220 volts with the coil. And then 92 UF is resonating coil B. And that's it. I'm not doing anything else with it. You can just barely see a small, tiny little spark. I don't know if you guys can see that. Like nothing there. But it's enough influence of creating a bounce in the silicon steel that's in the center. So I had a I think it was either 11 or 12 volts increase on the output. So that's interesting. Down the line, to squeeze even more out of this is just a series up a rheostat in series with the capacitance between these two capacitors. Man, I can feel this thing here. It's like I don't have a shirt on, you know. It's just too hot. Got a fan blowing on me, but I can feel the radiant heat off of that thing. It's just crazy. Yep. We got the 10, 112, 113 over here on this side. Yeah, 113, 110 in the middle. That's odd. And 112 down here. 113 over here. How do you think, guys? Let's see. Let's see, connect electric. No, Doug, what I've done is I'm only resonating C with 20.75 UF through two different windings in here. So one's a 100-volt winding and the other one's 120 140 volt winding in series. So it looks like 220, 230 volts impedance. And on the center, on the coil B, I've got 92 UF across that coil, the 100-volt coil, doing nothing else but just that. Just adding capacitance to that coil B. And we're driving A. And there's a significant increase. I didn't add enough capacitance. I worked my way up all the way from 1 U way up. And you know, it's some odd and even increments, but I found the peak up here, and it's like, okay, this is different. I've never seen. Usually, you do nothing with it with B, and or you can take the two of them and series them up, phase them up. But that doesn't seem to me. I tried that initially before I started recording, and I didn't like what was going on. It didn't seem like there was an advantage there at all. So that's seriesing up B and C together. In phase or out of phase. So 92 UF on coil B, 100-volt tap, and 20.75 on coil C. And we're getting almost 10 amps. And hardly nothing registering on the amp probe on the black. I've never seen this be with this much. 1600 watts. They've got a load of 1600 watts right here. And even if these things are off by 10%, it's still a 1,500 watt load. So something to think about. I apologize for that loud noise. My wife just opened up the door and threw a box at me. Yeah, it is interesting. So this is the grid coming in right here, which I've got just underneath the rag. And this is coming in here. This is the white and black right here, going through the amp probe. So this is the grid coming in. I'm just putting it underneath there to keep it from tugging on this stuff. So driving here, resonating B. We're not doing anything with it other than 92 UF across. I don't have. I wish I could find another one of these transformers. That'd be awesome if one of these came in again, because I'd love to put shunt bars on this. Having another core, just cut all the, just get the steel, and put shunt bars on this and drive the middle and resonate the two outside ones. I know Hector doesn't like that type of, what does he call them, Doug? What he calls the shunt bars? He's got a special name for them. $115, 115 degrees on both ends. Yeah, solid 115. So this transformer is warming up. It's expected. Kind of makes sense, really. Yeah, 115 degrees. So let's see if it goes up from here. Still got 490 something. Yeah, right around 490 degrees on the heat. Ambient temperature on the caps. I don't know if it, can you guys hear that? I don't know if you guys can hear this or not. Let me shut the fan off for a second. I'm sure you can hear the fan. But if you, all right, the fan is off now. See if you can hear the transformer. It's buzzing like a mother. Let me just turn the fan back on. And it's definitely squealing down this end. Buzzing pretty good. 116. Yeah, 116. This is warming up, and it's changing quicker now. Still almost 10 amps. This is interesting. So now the input looks like it's almost touching 400 mils, maybe 5. No, it's not. It's probably somewhere between 300 and 400 mils right now. So we're probably coming up on 9 or 10 watts in. Oh, waste. That's what it's costing us. Solid almost 10 here. $116. Yeah, this is getting harder quicker now. So we're at 116 degrees. I'm willing to bet you this thing would really, running this thing in the freezer, that would be an incredible experiment to find out if there's an increase. What do you think, Doug? Yeah, the transverter. Yeah, I don't know. You know, when you think in the RF world of a transverter, that's a different ball game. So myself, I guess it works, but my idea of a transverter is something totally different. Nothing related to power, RF energy more than, I don't know. Yeah, it's just a word. God damn right. Oh, 118. Yeah, 118. It's getting hot. And what's happening is the noticeable effect. We're still got our almost 10 amps over here, but now we're definitely on a 500 mil line. A half an amp right now at 127 volts. So that's where it shows right here. When this gets hot, your increase goes up. Your cost goes up. Yeah, still the same, 118. So even still, then you know what? It drops to zero as soon as I take the 10 amps off. When it comes back up, it's not quite making it to the 500 mil mark. It's like a needle width difference from being on it, right next to it. As this gets hotter, we can measure our losses right here. Yeah, 119 now. So this is, I wonder where this is going to go. 119 degrees. I'm going to put move the scope probe out of the way. I don't want it to get hot. Still 119. This is crazy, isn't it, Doug? Almost 10 amps measured here from coil C. And right now, at its worst moment, it's costing us, it's almost coming up on that 500 mil line. So it's more than 400 milliamps at 127 volts. On 19, maybe this is it. Maybe that's the peak. Yeah, I had earlier when I started this video, I had this clip lead in here which started to melt. But I had it actually seriesing up the 100 volt tap to the other 120 volt tap. And I had to take it out, put a heavier one in. Yeah, it's definitely, yeah, 119. Oh, there we go, 120. Yeah, the majority of it's 120. So yeah, so we're 120 degrees. Transformer is generating 120 degrees of waste. Imagine, Doug, what do you think this would do in a freezer at like 20 or 30 below? You think it'd be, I wonder if this would go to zero. Hmm, 120. Nothing's changed. It's right at 120. Maybe that's where it'll stop. $490. So the heat is $490 on the load. Still drawing almost 10. Now it looks like almost 500 mils on the input is 127 volts. Still 120 degrees. Yeah, pretty solid all the way around, 120. Yeah, imagine dunking this thing in liquid nitrogen. That'd be kind of cool. So 600 mils at 127 volts, 60 hertz. Output, still 10 amps almost at 160, 159. It bounces, it's up and down a little, but it's right in the 159, 160 area. Still at 122. Yeah, so 122 degrees temperature on the transformer. Yeah, I think I got one of those inverters handy to grab. I'll just pull it out anyways. Where are they?
Listen, I just want to take a moment and ask you to subscribe if you haven't done that already, and share the video and give me a thumbs up. Those three things go a long way in supporting this channel, and I really appreciate it. Thank you.
Yeah, I got that off of discount on eBay. Somebody sold it. They weren't sure if it no box, no owner's manual, no nothing. Um, I think I paid $90 for it. I think it's a $200, 180, $190 item. So didn't pay much for it. But the first thing I did is went in there to look at to see what was going on and how it was controlled, and I got the pinouts on that chip that's in there, so can make its increase or decrease frequency, I think, pretty easily. You still out here, Flint? Then you go to bed already, buddy. A wizard Harry, you're a wizard Harry. My Harry, hey, my name is Tim John, not Harry. A couple of minutes have passed. We have increase. No, no, that's the same. So 122 is the peak here, I think. We're still drawing almost 10 amps. And we're looking like we're drawing better than 500 mils at 127 volts right now. So not much input. I wonder if even the meter can even catch what's happening 60 times a second. That's like we're taking some and giving it back, and taking some and giving it back. I wonder. Interesting. The little compass, it rattles. There's a lot going on in here. Definitely a lot going on in here. I'm 22. Yeah, so I guess 122 degrees is what we're generating on a 90, almost 10 amp load. That's, I think this is unbelievable. Unbelievable. Yeah, all right. Sounds good, Doug. Yeah, I've looked at a lot of different inverters, and they all seem to try to avoid infringement of some sort. So there's like 3 or 4 different schemes they use for frequency control, and some of the inverters use a oh, you're welcome, buddy. Yeah, thanks for coming and hanging out and wasting your time with me. Yeah, I hardly ever go live, but you know what? It's like, you know what? Doug went live yesterday, so I just had to do it. Yeah. And then I figured I was going to do it with this. I had this idea this morning. I was like, you know what? I haven't messed with this yet. Let's do it live. Like Dave Riley said. You guys remember that? Dave Riley? Fuck it, we'll do it live. You know? So that's what we did. And look at what we got. For the cost of a little over a half an amp at 127 volts, we're getting 160 something volts, 159, 160 volts out, resonated with 20.75 UF into a resistive load at almost 10 amps. That's a considerable amount of energy. Yeah, this is definitely 122. It's capped out right there. We're not increasing at all. So let's see what happens. So we'll do this for a few more minutes, and if they don't increase, then that's not bad. There's so much heat coming off of this. I could barely feel anything radiant around here, but this is crazy. Let's see. There's more stuff going. Yeah, somebody's probably already done this. Hector's done it. You got Thane Hines. A lot of people. There's a lot of people on YouTube right now that have got different versions of this. Doug, how many hours have you put in this stuff? And actually, I'm taking the quick and dirty way out. I'm just trying to get, well, not come from a scrapyard, but essentially it's an off-the-shelf item, which I always love the idea. It's already made. Let's just violate that thing somehow in an unconventional way, right? I mean, that's just a run-of-the-mill, nothing fancy, 3-phase transformer. And look at what we're doing. With no shunt bars. Running it like Hector says, it's a transverter. I just like to say a single-ended bitoroid bit. It's just single-ended, you know. But whatever. Yeah, 122. So 122 degrees. That's not bad. That's all we have to worry about. Oh yeah, most definitely. This will be on there. You guys can watch this, and I might I don't even know how long when I started, but I know it's a long video now. What do we got here? I started at 4 minutes after 5, and it's 7:20 now. So I might break this up into 2 or 3 videos, or hell, I might just keep it. I'm just gonna leave it alone because it's. Yeah, I just leave it alone. It'll be there for anybody that wants to relive the moment. All right, so just for a general recap, 127 volts coming in at roughly 600 milliamps at 122 degree temperature on the 3-phase transformer. We've got almost a 10 amp load, and we're using a heat bank, coil bank that's used for an air conditioner for heat, and we're only using one side of it. So we're drawing almost 10 amps. We're resonating with 92 UF in the 100 volt coil. On coil B, coil C is resonated with 20.75 UF to the tune of 160 volts, and at almost a 10 amp load. 400 milliamps in at 127 volts. That's crazy. I didn't expect that. So yeah, I think there's a lot of people that have spent a lot of time with the bit. I think some really never really grasped how it functions. But I know Doug has done a lot of work with it too. Still 122. So that's the peak. The heat. Not bad. All right, guys, I'm going to wrap this up. I appreciate everybody that's been hanging out. Doug, Heliac, Debut. What else did we have on here? $122. So I'd say that's it. That's the peak for heat. This is unbelievable. All right, guys. Feel free to download this video for personal use. Don't re-upload it anywhere. Definitely embed it if you want. That'll help the channel. If you haven't subscribed, which obviously you guys have subscribed because you're chatting. But any future viewers, you're going to have to subscribe if you want to leave it. Actually, you can't chat. That's just DVR, I think, like at that point. All right. See you guys soon. Thanks for visiting. Thanks for hanging out. Peace, man. Yes, sir. You too. Thank you. Thanks, Doug. Thanks, Flint.